Let me begin by acknowledging the traditional owners of the land on which we are meeting tonight, the Ngunnawal and Ngambri people. The Ngunnawal and Ngambri people never ceded the land on which we meet, but they gave us the honour of allowing this precinct to be called Canberra. And I therefore ask you all to join me in paying respect to their elders, past, present and emerging. My name's Paul Pickering. I'm the Director of the Australian Studies Institute here at the ANU, and it's our great pleasure to have helped support this wonderful event. Allow me to acknowledge the presence of distinguished guests. Mr. Da Cruz, representing the Embassy of the Democratic Republic of Timor-Leste. His Excellency Mr. John Mayo Kali, the High Commissioner of the Embassy of Papua New Guinea. Mrs. Vivian Amana Veer Kelly, the partner of the High Commissioner of Papua New Guinea. Ms. Lohia Amanda Vivine Kali, the daughter of the High Commissioner, and Her Excellency Hinaru Petana, the Samoan High Commissioner, and Mr. Hu Yip Sung Kun, the First Secretary of the High Commission of Malaysia. And of course, a special welcome to members of the Mulvaney family. It's a great pleasure for me to have the opportunity to begin proceedings tonight. John, of course, was known as often referred to as the father of Australian archaeology. And I remember many years ago when I ran summer schools for teachers at ANU, the highlight of the entire week was when John gave them a guided tour of the galleries down at the National Museum. And of course his association with the ANU is of long standing. It gives me, therefore, great pleasure to pass over to my colleague and friend, Duncan Wright, who will introduce our speaker tonight. But I've been asked to mention that those who have RSVP'd can join us afterwards for drinks and nibbles at Badger. So please allow me to pass on to Duncan. Thank you.
Okay, so on behalf of the School of Archaeology and Anthropology, we welcome you to the 2022 Mulvaney Lecture. I would like to, as well as the wonderful people who have just been acknowledged, also acknowledge that we have a number of interstate visitors, so many colleagues from around Australia, so it's wonderful that you could be here. We also have a number of the ANU exec here, and we seem to have a large chunk of the Department of Climate Change, Energy, Environment and Water here, so that's fantastic too. We also have the head of the Australian Indigenous Archaeologists Association, and let's not forget all of the ANU students who have turned up today. It's fantastic to have you here, and we hope that you will be presenting the Mulvaney Lecture in maybe 50 years' time also. There is one person who, to be honest, I'm a little worried about being in the audience, but looking at the attendee list, there is someone called Pickled Gnome. So, all right, we may meet Pickled Gnome, he or she, in the Badger & Co. Afterwards. I also want to thank and acknowledge the contribution of the Australian Studies Institute, headed by Paul here, and also the wonderful contribution made by the School of Archaeology and Anthropology, Hal Admin, for helping out, Melinda helping out with, helping me organise this event, so that was wonderful. We also have 2 student volunteers that you probably saw on the way up, and please do introduce yourself. They're very excited, apparently, to meet everyone. Look, they're waving at you. And they very much want to meet you afterwards. Okay, so Sue was very clear about the fact she didn't want me to say very much about her. And I have to say that is quite hard because she has done a huge amount in her career. She is arguably the preeminent active scholar dealing with the prehistory or deep history, or whatever we want to call it, of island Southeast Asia. And of course, that is extremely relevant to many of our special guests here today in the Pacific and Australia. So she is also a distinguished professor at ANU. She is an ARC laureate. She was awarded the Rhys-Jones Medal as well. She has written just a disgusting number of publications. It's over 200 journal articles and book chapters. She's written 9 books. What is, to me, extremely exciting about this presentation is that all of these little snapshots, these little vignettes of exciting island Southeast Asian research and Australian research, they are all coming together for the first time in front of all of you guys. So I would like you all to give a warm welcome to our Mulvaney speaker for 2022, Professor Sue O'Connor.
Thank you, Duncan, for that introduction. Paul has acknowledged the first Australians on whose land we meet this evening. So I'd like to move on and acknowledge the landowners and local people of Timor-Leste and the diverse islands of Indonesia where this research was undertaken. So in tonight's lecture, I hope to provide you with a glimpse into the remarkable story of modern human settlement in our region. The topic of this Mulvaney Lecture is an appropriate tribute to the late John Mulvaney, as he was one of the first Australian archaeologists to recognise the significance of the islands to Australia's north. Although I could find no mention of it in any of John's obituaries, he was a founding member and joint leader with Paksiono, the Indonesian archaeologist, of the Australian-Indonesian 1969 scientific expedition to Sulawesi. So from the time of Alfred Russel Wallace's travels in the middle of the 19th century, research in the Indonesian islands, known collectively as Wallacea, which I'll be talking about tonight, has played an important role in European thought into the origins of humanity. Mulvaney had been working in Australia, and in looking for external linkages, it was natural for him to gaze north to the islands to our north. He also had PhD students working on related topics. Ian Glover was working in what was then Portuguese Timor, which is now the independent nation of East Timor, and Campbell McKnight was investigating the Sulawesi trepang trade and Macassan voyaging to Arnhem Land on the Australian coast. In late 1968, the Indonesian archaeologist Siono came to Canberra and met with John, and together they began planning the 1969 scientific expedition to Sulawesi. Joining the expedition were several young Indonesian archaeologists, and on the Australian side were Ian and Emily Glover, née Coleman, and Campbell McKnight. One of the sites they investigated was the now famous site of Liang Burung 1. In the slide on the left, you can see John partaking in coconut for morning tea at Liang Burung with Campbell and Paksiono on the right-hand side. And the slide on the right, I think, shows Emily with John. They're all wearing sarongs. John's in his still wearing his trousers, much more formal chap. And Campbell McKnight and Ian Glover, and they were singing at a concert in this slide. You can see them singing in this slide. So the Maros region, as many of you will know, has recently been catapulted to international prominence with papers in Nature on the dating of its rock art, which has an antiquity of 45,000 years of age or greater. That work was done by Professor Maxime Aubert, who's now at Griffith University, but who was at ANU during his PhD. So why is Wallacea so significant? this area called Wallacea. Well, the Wallacean Islands have always been separated by ocean from continental mainland Asia, or the Sunda Shelf, and Sahul, which is the expanded landmass, which includes Australia and New Guinea. You can see Borneo and Java connected to the Sunda Shelf, shown in grey in the slide, forming Sundaland, the megacontinent of Sundaland, and New Guinea and Australia and the Aru Islands on the right, forming Sahul land, the Pleistocene continent of Sahul. In the middle, in green, is Wallacea. And as you can see, this region was not connected even at lowest sea stand. So here we've got the sea stand at minus 120,000 years ago, which is the lowest sea stand during the period of human occupation of this region. And these islands are still all separated. So as John recognised, reaching Australia and New Guinea at any time required multiple water crossings. So the place, he thought, that we should look for this early evidence for people who came to Australia was Wallacea. And that was his rationale for the 1969 scientific expedition to Sulawesi. However, modern humans weren't the first to cross Wallace's line. Until recently, we thought they were, but then all that changed with the discovery of the Hobbit. Archaic hominins, including the Hobbit, managed to get to at least 3 of the large islands just east of Wallace's line: Sulawesi, the Philippines, and Flores. And they managed to do this between about 1 million years ago and 700,000 years ago, so a long time before modern humans. However, the islands they reached were the largest and the closest to the Sunda mainland. And they had abundant large to medium-sized fauna, so they were quite different to the other islands, the smaller islands in Wallacea. The restricted distribution of these archaic hominins suggests that the archaic dispersal was likely accidental, or at least that's what I've argued. It wasn't purposive. And I've also argued that water crossings presented a barrier for non-modern hominins. So they got that far to Sulawesi, the Philippines, and Flores, but they didn't get to these islands further to the east. In contrast, modern humans dispersed to even the smallest islands during the Pleistocene. And I've argued that this indicates a different threshold of maritime capacity for modern humans, one involving purposive watercraft technology, purposive voyaging, the quite developed or much more developed watercraft technology, and a much greater maritime capacity. It's not just that the Wallacean Islands are difficult to get to, that they require these water crossings. Once you leave those ones like the Philippines, Sulawesi and Flores, which had some large to medium-sized animals on it, they're also very challenging to make a living on, these smaller islands. The Wallacean Islands, with the exception of Sulawesi, have unbalanced and depauperate terrestrial faunas. So in the past, the islands which were closest to the Asian mainland, such as Flores, Timor, Sulawesi, Sumba, had at least one species of these stegodons, and some of them had a succession of stegodons. Stegodons are a giant extinct genus, which are related to modern elephants, slightly distantly. They also had a giant monitor lizard, which was like the Komodos, and they had an enormous land turtle. But with the exception of the Komodos, these are all extinct today. On Flores and Sulawesi, these animals coexisted with archaic hominins. But based on current research, it appears that they went extinct close to or at the time modern humans reached these islands. So why did they go extinct? It's a like a lot of people have said, well, it's really coincidental that you get, as soon as you get modern humans, we lose the archaic hominins and we lose all the giant fauna that we had in these islands. Well, we don't have the answer to that yet. That's another reason to continue to do more work in this fascinating area. But climate change, volcanism, and modern human extirpation of the giant fauna and the hobbits have all been brought up as reasonable hypotheses to explain their co-disappearance. But so far there are no winning candidates. Fauna on the smaller islands, as I said, the smaller islands of Wallacea, consisted of no more than rodents, bats, and small reptiles. Giant rats are found in some of the islands, and some giant rat genera still exist today in a few islands such as Flores and Obi, the Obi Islands. And in the slide on the left, you can see an individual of the giant rat Papagomes from Flores, which is still extant today. And Timor-Leste had 6 of these whoppers, these whopper murids, which were up to between like 6 and 8 kilos, the biggest one in size. So the size of a cat. So a fairly intimidating murid. But sadly, the Timor monster murids are all extinct today. I think it's sad anyway. But the archaeology shows us that they persisted until about 1,500 years ago. So they were there until very recently, in the modern human record. On the smallest islands, such as Kisar, we had even less fauna, just small murids and small, very like bats and small birds, etc. So I've argued that this is part and parcel of why archaic hominins were restricted to the large islands immediately to the east of Wallace's Line, in that they appear to have been reliant on medium to large fauna. They weren't able to cross they were able to get across the Wallace Line, probably by accident, and once in these islands could make a living on Sulawesi and Flores because they had this large fauna, but they weren't able to move on into the islands which only had smaller fauna. So the 2 top slides, the one on the left shows Homo floresiensis, the hobbit, engaging in a stegodon kill. And the one on the right shows Homo luzonensis dispatching a rhinoceros. Whether they actually did this or whether it was predominantly scavenging, we don't know. But they're great illustrations, aren't they? But as I've said, on the smaller, more distant eastern islands, there wasn't any such large game. To make a living on these islands required the use of the abundant marine resources from the surrounding seas. The archaic hominins, such as Homo floresiensis, lacked this ability. They lacked the watercraft and they lacked the ability to exploit maritime resources effectively, so they couldn't move further east. Okay, modern humans, however, are a completely different ballgame. The Australian evidence from the Arnhem Land site of Madjababy indicates that modern humans crossed the Wallace Line between 65,000 and 50,000 years ago, depending on whose interpretation you believe. I won't get into the dating debate. Despite this evidence, however, and concerted survey and excavation efforts over the last decade, we've failed to produce any sites associated with modern human occupation dated anywhere this early in Wallacea thus far. In the island of Flores, at the famous Liangbua site, home of the Hobbit, modern humans occur in layers directly overlying the Hobbit layers, where they date to about 47,000 years ago, plus or minus a few thousand. And thus far, there's no evidence, as I said, no definite evidence of overlap between the two species. In Timor, modern humans appear about 45,000 years ago, plus or minus a few thousand. In Alor and surrounding islands, we're looking at about 40,000 to 42,000. So you can see all of the dates are falling out about the same age, but they're not nearly as early as the Australian sites. So how did modern humans get all the way to Sahul? Well, the routes taken by modern humans are still debated. And again, despite concerted modelling efforts over the last decade, we're still no wiser about which route was most likely. Two primary maritime routes through Wallacea were proposed by Joseph Birdsall in 1977 on the basis of the number of islands and intervisibility between islands and distance between islands as most parsimonious for getting to Sahul. And that's a route A, which you can see here on the bottom in purple, which goes through Java, through Nusa Tenggara and Timor-Leste, and then onto the expanded Arnhem Land shelf, coming out near Majubaby, which is, Chris Clarkson likes that, the route, the closeness of the landing point to his sites in Arnhem Land. And then there's route B, which takes early modern humans through Sulawesi and either up through Halmahera or through Seram and onto the expanded coastline of Sahul near the Aru Islands, which you can see where the site of Liang Lemdubu is. Recent modelling efforts suggest the northern route as the most parsimonious, have suggested the northern route as the most parsimonious, but intensified field exploration has failed to resolve this issue, which is great because we all get to do a lot more field work looking to field test these propositions. I actually think it's likely that the early colonists didn't move onward in a unidirectional or least cost pathway type of way, but rather that islands, once an island was reached, that islands in close proximity where currents and winds were favourable were visited over generations. People became familiar with those islands that were visited, and the new islands might have been then settled, and the same process would happen again. Depending on currents and wind direction at different seasons of the year, this isn't necessarily going to move population eastward. Populations could have been moving in multi-directions simultaneously over generational timescales, and in this scenario, modern humans quite likely utilise both routes simultaneously, because our dates suggest that once modern humans started moving through the archipelago, they are moving populations are moving quite rapidly in a generational sense. Okay, so in tonight's lecture, I'm going to focus primarily on modern human occupation after that brief introduction and what we know about them following settlement of Wallacea. In this slide are photos taken in the small hamlet of Tutuala. It's an extremely beautiful place in Timor-Leste, which I would recommend people visit. It's really stunning and unspoilt. As you can see from these images, it looks like this today. As you can also see in the images, this region has extremely steep topography. The image bottom left is the well-known site of Ilikerikeri, which is a fabulous rock art site, you can see that you wouldn't want your toddlers running around in that rock shelter because it's just the drop-off is precipitous and it's down about 30 metres. This area has very steep topography, which is caused by the uplift of the limestone. So you can see in the upper right slide that you have stepping in the limestone, which is from the uplift of the coral reef over time, which is why you end up with these great cliff exposures where you get erosion forming caves and rock shelters. So the significance of this is that the uplifting of the limestone reef means that these sites, when they were occupied, were, as opposed to areas which are subsiding, these sites were taken away from coastal influence. So the deposits were protected. So you get this fabulous record. But the other significance of this is that the bathymetry offshore is as steep as the topography on the land. So immediately off the coastline, it drops very steeply down to the continental shelf. And what this means is that at any sea level, pretty much during the period of human occupation, you've never been very far from the coastline, from the Pleistocene coastline. So even though sea levels go up and down, these areas have always been within a few kilometres of the position where they are today. And that means that what you can capture in these sites is Pleistocene coastal occupation. This is markedly different from the situation we have in most areas of the world where earliest colonisation around coastlines has been drowned by rising sea levels. Okay, graphs. I won't dwell too long on the graphs because I know how much everyone loves graphs. But this graph shows occupation sites dated in a handful of occupation sites, not all of them, that are in Wallacea, dated between 47,000 and 17,000. And it shows the intensity of occupation at those sites, based on number of stone artefacts by unit volume of sediment. Earliest modern human occupation in Wallacea is characterised, as you can see, by generally low intensity use of a small number of sites. Only a handful of sites are occupied by about 45,000, and these are Liang Bua, the famous Hobbit site in Flores, Mat Pan, a site that our team excavated in Alor, Lai Li, Jeri Malai, which is now called Asitakuru, and Machakuru 2 in Timor-Leste, and that's about it. The rock art dating in Sulawesi also indicates that Sulawesi was occupied by 45,000 by modern humans, not by archaic hominins. So as you can see from the graph, all sites show a low level of occupation following first settlement, with little change until about the terminal Pleistocene. With the exception of Liang Bua in Sulawesi, all the earliest sites are also coastal or near coastal locations. Now, this might be a sampling issue. It might be that archaeologists like to go and look at sites near the coast, and I'd be amongst them. And having recently decided to work on an island called Obi, which was densely forested, I now know why. I will be going back to islands like Timor-Leste and looking at areas near the coast. They're extremely difficult to work in. So it might be sampling, but also these coastal sites all show a really heavy reliance on marine resources. So what did Homo sapiens do when they first got there? They focused on those marine resources. This may be due to the fact that on these islands, apart from the islands like Sulawesi, the big islands with the terrestrial fauna, these smaller islands don't have very much inland in the way of land species that can be game, that you can hunt. So you've presumably got the vegetable foods that we don't get in the archaeological record inland. But in terms of game species, there's not much to hunt on these smaller islands. Whereas on the coast, we have abundant and predictable coastal resources. So it makes sense that when a new population moves into an area, that this is what they're familiar with and that this is what they focus on first. Okay, we've recently had some confirmation of this in the isotopic signatures in the teeth of the earliest human arrivals of teeth found in I think it was Lenihara cave in Timor, which date to about 40,000 and which confirm that the diet was almost exclusively marine. And the teeth that come in the later levels show more of a switch to terrestrial resources. But this first specimen indicates a virtually exclusively marine diet. So the sites of Asita Kuru, the earliest sites contain fauna, as I said, from a diverse range of catchments. So they do have some, the earliest coastal sites, they do have some of the giant rats and they do have birds, but by far the most abundant resources are the fish, shellfish, crustacea, turtles, and other marine animals in the assemblages. Now, Asita Kuru, which used to be called Jeri Malai, but when I went back there to re-excavate it, the locals said to me, "Why did you call it Jeri Malai?" Because that site's on the other side of the road. This site's called Asita Kuru. And I said, "Oh, I called it Jeri Malai because that's what I was told to call it." And they said, "Well, you'll have to change the name." So I have, which is a bit confusing. But Asita Kuru / Jeri Malai has abundant evidence for fishing. Abundant evidence. Fish make up the majority of the faunal remains. It also has evidence for pelagic fishing or fishing of pelagic species such as tuna at this early date in the levels from 45, 47,000 up until 17,000. There is abundant evidence of pelagic fishing. But no fish hooks, no evidence of fishing technology. So it's possible that people used wooden tools such as wooden spears or nets, which just simply don't preserve. We don't know. The stone artefacts in these very first early modern human levels are simple stone tools, mostly made of chert, no axes. And for all of you who know the Australian record, this is quite unusual because our earliest Australian sites in Northern Australia have polished stone axes. We simply don't get them in these early levels of the Wallacean sites. So in summary, the earliest sites demonstrate how much more versatile modern humans were than the archaic hominins. They can eat anything. They can basically make a living on these small, very difficult islands. They were generalists able to exploit a wide range of environments that had virtually no terrestrial game. But in terms of technology, their technology wasn't very complex. The one exception is this remarkable bone artefact from Machakuru 2 in Timor-Leste, and this is just the halved end of the artefact that you're looking at. The end that would have gone into the spear butt, the butt end that would have gone into been hafted into the spear. You can see in the top right-hand corner. It's got these serrations like some of the early African harpoon heads, and this is a reconstruction of how we think it would have operated and been bound. So essentially bound with some sort of fibre binding around these serrations. It's missing the actual point, the pointy end of the spear or harpoon. You can see this is actually Machakuru 1, the next door cave to Machakuru 2. In the slide on the right, I had to put this in because it shows a very young Matthew Spriggs when we were there doing this excavation, looking over his glasses quizzically at the camera. And you can see on this remarkable bone artefact that there are traces of mastic and which are still remaining. Now, this artefact is 32,000 years old, and it's quite exceptional. There is nothing else like it in our Timor-Leste assemblages. And in fact, we still don't know what it's made out of because there really aren't any large land animals that it could have been made out of. So it could be human bone, it could be dugong, potentially. And one of the things we're going to try and find out is what was this made out of. Okay, So apart from that artifact, fairly simple technology in the Pleistocene. But all of this changed dramatically at 17,000 years ago, because at this time, major changes take place throughout the archipelago, evidencing maritime interaction between populations on different islands. So for the first time, we actually see populations moving between islands and having contact. From this time onwards, we also see even the smallest islands in Wallacea were occupied. Now, the slide on the left is the island of Kisar, the Google image of Kisar, which is slightly north of Timor-Leste, the east end of Timor-Leste. And it's a tiny island which has fabulous woven cloths. So some people do know about it. It's famous for its textiles. But it's only about 6 by 8 kilometres. So you can see how small it is and would have been incredibly difficult to make a living on. The population would have been predominant, almost entirely reliant on marine resources. This is on the slide on the right, you can see our excavations, 2 small test pits at the site of Heri Sarot and Tapa. And this site was first occupied about 16,000 years ago. So as I say, in this time period, after 17,000, even the smallest islands appear to have been occupied. Okay, this is these more graphs. Sorry, at least they're not pollen diagrams. Okay, so note the. As you can see, all the sites, all of the same sites I showed you before and a few more, which have now been occupied in this phase after the LGM, show a major step up in occupation intensity about 17,000 years ago. So in the terminal Pleistocene, we see this massive increase in occupation intensity in sites which were already occupied, and a whole lot of new sites like small islands, sites on small islands like Kisar come online. Why? Why does this happen? So what factors are responsible for the changes in population and settlement that occur about 17,000 years ago? There are a number of changes in technology that we begin to see at this time, which correspond to this major step up in occupation and this much wider use of the archipelago. And we think that many of these changes in technology signal increased maritime movement between the islands and interaction between these distant communities. And these include, as the slide says, the appearance of shell adzes, exotic imported obsidian tools. Obsidian is a type of volcanic glass. And fish hooks appear in large numbers from about 17,000 years ago. And these distinctive two-holed beads, and also singular beads made on nautilus shell. So you can see the distribution of these finds marked in yellow. And I also put yellow dotted lines where we don't have a contiguous distribution, but where the distribution might be contiguous. So you've got the dotted lines joining up, for example, Roti in the west with Kisar for the shell beads. And you can see the shell adze distribution is really quite extensive. Okay, shell adzes extend right out into Oceania. This map shows their distribution, and it extends from the Philippines across Wallacea and into Oceania in Manus. The earliest adzes are found on Obi Island, and we found these a few years ago, just the year before COVID hit and wiped out all our fieldwork plans for the next few years. And you can see the site of Kilo 6 marked in yellow there. And that's where we've got the earliest evidence of shell adzes. Other finds date between about 13,000 and about 7,000, these other finds, and about 7,000. You can see our tiny kilo excavation at the bottom right. It's just a 1 metre test pit. Now the adzes are made exclusively on the hinges of these tridacna shells, tridacna or hippopus, clam shells. And they're made on the hinges, or some of them on the valves, but most of them on the hinges. And you can see some of the finished adzes that we've found in Timor-Leste there in the slides. But apart from the adzes themselves, the finished ones, now that we know that we should be finding them, we've started looking at the shell assemblages. And you can see those top flakes above the whole adzes. They're flakes which have grinding on, which demonstrate that they were once part of axes or adzes. They've come off the edge of axes. These have probably been missed. So when we look at our distribution and it's not contiguous with the dotted line, I think many of these assemblages, people used to go out, they'd excavate, they'd get a whole lot of marine shell, they'd keep a few for radiocarbon dating or a column sample to describe what was in the assemblage. But most of the assemblage of shell, they left behind at the place of excavation because it was just too much to bring back. I suspect we've lost a lot of this evidence. We've left it behind in the field because these small flakes with evidence of grinding, they're quite hard to find without looking at them under good magnification. They just look like bits of shell. So once we found the whole adzes, we started looking really carefully. So it's possible that the distribution is much broader. What were they used for? We think these adzes were used for heavy-duty woodworking, for tasks such as the manufacture of dugout canoes. Now, why do we think that? Well, ethnographic accounts from throughout the Pacific indicate, like accounts from Fiji, Tonga, and other Pacific islands, indicate that shell adzes, such as the one on the right in the slide, bottom right, were almost as efficient as stone adzes. And this surprises a lot of people. They think, oh, you know, shell adzes of tridacna, they wouldn't be very efficient. They wouldn't last very long. They wouldn't be very good for heavy-duty woodworking. But these ethnographic accounts show that they were, even in places where really good quality hard stone, like volcanic stone, was available to make axes, people still made adzes out of shell. Now, they didn't last as long, the working edges didn't last as long, but they were much easier to go and find another clamshell and make yourself another clamshell adze. And they were much easier to rework, and so even if they didn't last as long, they were pretty efficient. So as I said, they were used widely, even in islands where good stone was available. So why? Why do they appear about 17, 16, 17, well, no, it's actually later, 15, 14,000 years ago? Well, it's quite likely that this began, we have argued, as a response to changes in climate. Because at the end of the last ice age, the last glacial maximum, conditions become warmer and wetter. And in many of these islands, such as Obi, now you can see the slide in the middle is from Obi. That gives you some idea of what the vegetation's like. It's a nightmare. It's impenetrable. You can be standing in front of a rock shelter and it can be a metre away and you simply can't see it. So if the vegetation became warmer, if it got warmer and wetter and the vegetation got denser and forests closed in, it's quite likely that ground shell technology was a response to that, used for forest clearing the rainforest, making patchy openings in the forest. And also, it's quite likely that more effort would have been put onto coastal areas, exploiting coastal areas which weren't as dense, where the forest wasn't as dense, and watercraft would have been needed. Also, at the end of the LGM, as sea levels rose, even though this area has the steep topography, some islands were divided into smaller islands. So populations would have been separated from kin. And if populations wanted to stay in contact, better maritime technology would have been necessary. So perhaps this is why adzes were developed, shell adze technology, and maybe perhaps spread from the wetter areas like like Manus or Obi, and then spread to the west. About the same time as the shell adzes appear, we have tiny obsidian artifacts. Now these really are tiny. You can see the scale, but a centimetre, 2 centimetres is a large artifact. They begin to appear, they come from an unknown island. So that's the first thing I'll say. You can see the distribution in yellow. So that shows you the distribution of where we find these obsidian glass artifacts. But where do they come from? We simply don't know. So they first appear in Kisar Island 15,000 years ago. That's the earliest date that we have for these obsidian artifacts. And they certainly don't come from Kisar. Kisar is a limestone island. It's got no volcanism. There's no possibility they're getting the obsidian from there. They don't come from Timor-Leste. We find them in Timor-Leste. We find them all around the coast of the Timor-Leste sites. But they're not from there. Timor is, again, a limestone island. We find them in Alor, which is volcanic, but they don't appear to be from Alor. So the obsidian, we've called it, Christian Rietmeyer, who's done the PXRF analysis on these artifacts, has called it Group 1 obsidian. Not a very imaginative name, and we think, we don't yet know where it comes from. We've geochemically fingerprinted them, so we know they're all Group 1. They all appear at about this time, earliest in Kisar 15,000, Timor-Leste 13,000, slightly later than that in Alor. So the distribution suggests that they're moving west. Where did they come from? Well, we don't yet know, but we're punting on Wetar, which is the island with the question mark at the top of the right-hand slide with the red question mark. The other dots show where they're distributed. The reason we think Wetar is likely is because it's volcanic, it's in the Banda Arc. And Shimona Keeley, who's here tonight, found some Indonesian geological reports which were written in the 1930s, one of which said that in Wetar they'd found a wall of glass. So we think that this is prospective, and if it wasn't for COVID, we'd have gone there already and had a look. But we're planning this hopefully next year. Okay, so notably also, Group 1 obsidian doesn't appear in the inland Timor sites. So I said after 17,000, we do get inland sites in Timor occupied, but we don't get Group 1 obsidian in those inland sites. The tools are all made on chert. So whatever this network is that's moving this obsidian around, it seems to be a coastal network. The obsidian is moving from one coastal location and one island to the next, but it's not going up into the inland areas. So what else appears at this time? Fish hooks. Another major technological advance. So as I said, we have plenty of evidence for fishing from 45,000 to 17,000, but no fish hooks. But after 17,000, fish hooks are found in all of these sites, all of those sites in Wallacea that I was talking about. Timor, Alor, Kisar, all of the Nusa Tenggara and southern Maluku sites. The oldest examples are in Timor-Leste, where they're amongst the earliest examples in the world. I did have the earliest fish hooks in the world, but a few years ago, somebody found some in Japan, which might be slightly older, but might not be, because the Japanese ones haven't been directly dated, and some of ours have been. So, as I say, they've been found in Alor and Kissa, dated to about 16,000, where we've got direct dates on the fishhooks themselves. It's possible that the distribution of fishhooks is much more extensive. We haven't yet explored and excavated other sites in southern Maluku, but you would think, logically, if these are an adaptation to small islands where you've got to base your whole subsistence on maritime technology, then you're going to find them on other small islands in southern Maluku, but not on the bigger islands like Sulawesi, where there is more abundant game. Okay, just those, that gives you some idea of the variety of fishhooks we have in our sites. And this slide shows a remarkable rock shelter in Alor known as Trombon Lay, which we've done 2 seasons of excavation at now. So our original test pit is to the left of the arrow, and then we expanded that pit, and you can see the extension to the right of the arrow. And it's about, less than 100 metres from the coast in this volcanic ridge line. And it's remarkable because it contains this incredible burial, which you can see in the slide on the left. This burial was excavated back, the head of the burial was excavated, I can't remember the date, I think it was 2014, but I'm probably wrong. 13? 14. We excavated in 2014, and as always happens, right at the end of the excavation, we found this burial, and we didn't have time to enlarge the excavation because we had a set field season, and based on our kitas or whatever, we couldn't stay longer. We didn't want to leave it because we were worried that people could think that we were looking for treasure and potentially dig it up, like local villagers were curious about why we were digging there. So we excavated the head. And at the time, we wrote a paper called Fishing in Life and Death in Antiquity, where we argued, based on the cranial measurements, or Sophia Sampacaro, who's here tonight, argued that it was most likely a female. But this was still putative because, as everyone or many of you will know, you can't actually be certain based on cranial measurements. You need the pelvis to be completely sure. So we went back and excavated again and enlarged the excavation, and we got the pelvis this time of this burial. Because when we initially published it saying we thought it was likely a woman who was buried with these fishhooks, the referees, even the editor of the journal, was like, oh, no, it's not going to be a woman if it's buried with fishhooks. So this 12,000-year-old burial is extraordinary. And again, as many of you who know the Southeast Asian record, it's very rare, even in mainland Southeast Asia, to have a Pleistocene burial with these sort of grave goods. So the fact that this is a female burial, buried with all these fishhooks, we've now found, when we went back and excavated the full skeleton, we found more fishhooks on the body, and she was buried with 6 fishhooks. And she was a mature age woman. She also had extreme wear on her teeth that suggested that she might have actually spent quite a bit of time making nets or some such thing. But this sort of burial with burial goods, high prestige burial, very unusual anywhere in Asia at this date. And the fact that it's a female burial makes it even more unusual. So you can see here the full burial as it was excavated with the position of the skull in the original pit and the rest of the burial on the photo at the bottom. The stratigraphic drawing in the top right-hand corner has the burial position marked on it. And there are two different, this is for Jim Fox, who said he wanted to see some fish hooks. There are two different sorts of fish hooks, which you can see here. There are large rotating fish hooks and there are jabbing hooks. And these are these are used for very different conditions. For example, when you're fishing. Large rotating hooks are used in deep water. They're used when the hook needs to be suspended off the bottom. So very windy conditions where you can't keep your hook, you can't keep your line steady. These rotating hooks are good. Or in situations where you're offshore and have a lot of coral bommies, because otherwise, if you have a hook which sits on the bottom, you're going to end up with your line snagged. So you use these rotating hooks, are free floating hooks, basically off the bottom. And what happens is they're suspended. The fish comes along. It sees this lovely shiny hook because they're made on nacreous shell, and it grabs the hook and it essentially runs with the hook and hooks itself. So as opposed to a jabbing hook, when the fish takes the bait, you tension the line and you catch the fish. These operate quite differently in different weather conditions, and the hook rotates and catches the fish. None of our hooks have a notch for attachment of the line. They are probably like the hook here, which is an ethnographic example, which you can see in B. The rotating hooks certainly are, and they were bound around the shank. And some of them have traces of mastic still on them, on the shank, indicating that some sort of resin was used as well to hold the binding. Okay, at the massive cave in Alor, which the locals call Macpan, which you can see Julian Loys, bottom right, squatting beside our excavation. This is an amazing cave. It's huge, and it's almost big enough to park an aeroplane in, to have as an aeroplane hangar. We had this massive assemblage of fish hooks, and we have hooks in various stages of production. So this gave us a really good idea about the chain of production, or chain operatoire of fish hook production. We also found coral fish hook files. So you can see the fish hook file up there on the left, and sinkers used for attaching to either lines or nets. And they appear there from about 14,000 years ago. So another change occurs in the terminal Pleistocene, and that's the appearance of these new types of personal ornamentation. Small disc beads, which are made on nautilus shell, are found across an extensive area, and you can see them marked on the map from Kisar, north of Timor-Leste, down to Roti. So they're these tiny, tiny little beads made of nautilus shell. They're very, very shiny and lustrous. And when we first found them, we only had the single beads, but now we've got lots of these two-hole beads, which date to about at least 12,500 years ago. And these are direct dates on the beads themselves. So there's no chance that these have actually moved down the profile. These have actually been directly dated. And the dates are in good stratigraphic accord with the other dates. Again, it's likely that these beads, like I said about the flakes off the axis, it's likely that they were much more extensive, but they're so small that they were probably missed in many of the early excavations. Like Van Heckering refers to beads, he says, are made of mother of pearl too in Flores, but there are no pictures and it's impossible to know, but it's likely that he's referring to the same type of beads. So these are really unusual, particularly the two-hole beads, because they're used as applique. So we actually have evidence that they've been sewn or stitched onto some sort of fabric. So we're talking about appliques 12,500 years ago, which are used for decorating clothing or some sort of, clothing or some sort of apparel that people are wearing. And that's really, really unusual to find them, that type of decoration this early. Also, we don't, like for a long time we thought, oh yes, the tropics, people didn't really wear clothes, so they actually didn't need these sort of decorations. And that was the reason that was argued that there wasn't much in the way of symbolic personal ornamentation in our region. But we now know that there's a lot more of this sort of symbolic personal ornamentation. We don't know exactly how the Nautilus shell beads were worn, as they haven't been used up into the period of written history. There were none used when people first went there and started recording or collecting for museum collections. And I haven't been able to find any examples in museum collections anywhere in the world. But you can see this, this headband, which is in the top and bottom corner, and they're a different type of applique bead. They're Nacerius shells, which are white, and they're on an ochred background. And we think perhaps the Nautilus were worn in a similar way, because many of the Nautilus shell beads, the little double-holed ones, have red ochre still on one side of the bead. So they're either attached to some sort of red material. Now, these Nacerius beads, that's a paper bark headband. It's paper bark which has been heavily ochred, and then the beads are attached. And you can see it makes a really amazing contrast. That was one that was worn apparently as a headhunting headband. So it's got the red ochre, which is the colour of headhunting. Now, we don't know about the Nacerius, our little Nautilus beads rather, but they do have red ochre on one side, so they were possibly used in the same way. And they may have been strung as a headband like this example from North Queensland, which is also beads made on Nautilus. In the top left, you can see a whole Nautilus shell. They're extremely large and beautiful shells. They're widely collected. People hang them off their houses throughout parts of Asia today as decorative items, and they've got the carving on. They're often carved. So finally, supporting the findings of the archaeology, recent genetic research in Wallacea has uncovered evidence to suggest migrations from Papua to Wallacea were occurring sometime after 18,000, with a peak around 15,000 years ago. I've put the papers up the top. You can't really see them, but there's a recent study by Panomo and colleagues, who's an Indonesian geneticist who's working in Adelaide. And another genomic study of modern mitochondrial DNA from the Philippines have recovered evidence for the arrival of Papuan ancestry in this region about 15,000 years ago. To date, the earliest successful recovery of ancient human DNA from Wallacea was from the 7,300-year-old Liang Peninje burial in southwest Sulawesi. Unsurprisingly, this mid-Holocene individual shares a common ancestor with Indigenous Australians and Papuans, likely reflecting the initial expansion of modern humans throughout Wallacea. So that Sulawesi individual, the ancient DNA, shows a connection with Papuans and with Australians. However, what's interesting is this Sulawesi individual, the Liang Peninje individual, doesn't have any evidence for this 15,000 east-west movement of Papuan ancestry. So the modern Sulawesi sequences in the Panomo study were also the only Wallacean sequences lacking this Papuan connection. So I think this provides really good support for our archaeological evidence which shows this amazing, essentially, movement in the Wallacean region, and including movement probably from Papua or from that area of near Oceania, from Maluku into Wallacea, and probably back. But there's this early movement in the region. And we're not just talking about one or two things moving. We've got quite a lot of these obsidian artifacts, for example. And there's no way that this can be a coincidence. The obsidian is all from the same group. So in conclusion, we don't have any evidence of modern human occupation yet in Wallacea as early as our Australian evidence from Majabibi in Arnhem Land, but logically it's got to be there somewhere. So that's all the more reason for us to go back and do more work. Early modern human economies were very flexible, but on the small islands they were almost exclusively reliant on marine resources. Very early on, we have plenty of evidence for marine resources, including fish, including tuna. So people are engaging in, big fisheries, but no evidence for this sort of complex technology that appears with this efflorescence in maritime endeavour after about 17,000 years ago. This also appears to be linked to the advent of ground shell adzes, which we've argued are used for making more efficient watercraft to move people around the archipelago, probably dugout canoes. And along with this comes traded obsidian, which is moved between these islands and may be much more extensive. We've only just scratched the surface with these few islands. We don't yet know how extensive this network was, but it doesn't appear to have extended north to Sulawesi, and that seems to be supported by the genomic data, which indicates both movement and exchange of genes between 18 and 15,000 years ago from Papua into southern Maluku and Nusa Tenggara, but not up into Sulawesi. There's something different going on up there. Regular exchange networks cementing reciprocity, and that's what these sort of exchange networks do. So people have said, why were they bothering to exchange these small pieces of obsidian? And why does anyone exchange anything? And it's often to have that network, to cement that network, to cement those kinship relationships. And one of the things that these type of reciprocity networks do is that they guarantee that you've got a network when things go wrong, which was probably necessary if you were on an island that was 6x8 like Kissa. You have a drought for 5 years, you've got a neighbouring island that you can call on because they use those obsidian tools and you use them too, even if they're just a signifier, even if they didn't have any specific function. The function may have just been to cement that reciprocity or those networks. So in summary, we think that these artefacts mark the onset, well, we've argued this, of the world's earliest maritime exchange network in our region, which I think is something that John would have been proud of. They're amazing discoveries over the last decade. So this region of Wallacea continues to repay the researchers who work there. To finish with the words of Campbell McKnight, who's here tonight, the joint leadership of Mulvaney and Siono set a precedent for collaboration and friendship between Indonesian and Australian archaeologists that endures to this day. And we can see that with the work of Campbell McKnight, Dave Bulbeck, Adam Braum, Max Obert in Sulawesi, Peter Bellwood throughout Wallacea, because Peter's worked everywhere. Dr. Zangrini, Mahirta, and Dowd Tanajuro were all PhD students at the ANU under Peter Bellwood, under his supervision, just as Ian Glover and Campbell McKnight were students of John's. Ian Glover, John's student, excavated in Portuguese Timor. Matthew Spriggs, who's here tonight. Peter Veth is also here tonight. Nuno Oliveira, who was my PhD student, who's overseas, continued this work following the establishment of an independent Timor-Leste. So we continued the work in Timor after it became an independent nation, and we were able to. So John's legacy continues to inspire a new generation of young archaeologists working in Indonesia and Australia. Okay, so that's it. I'd just like to say thank you for all coming tonight, and also to emphasise that the work I've presented tonight is it's not my work. It's work of a really big team. So it's the work of many people who are here tonight: Shimona Keeley, Sophia Sampacaro, Christian Rietmeyer, who's now in Germany, Stuart Hawkins, who's here tonight, Tim Maloney, who's in Queensland at Griffith, Michelle Langley, likewise, Julian Loys, also at Griffith. Yes, Griffith have poached all our wonderful ANU researchers. And Kerry Shipton, who's back in the UK. Doctors Mahida and Anggrani from the University of Gadjah Mada in Yogyakarta, and their students have been a massive part in these endeavours, and we wouldn't have been able to do the work without them. Matthew Spriggs and Peter Veth, who are here tonight, I'd like to say a special thank you to, as they were there in those early days of field work in Timor-Leste. And to the Indonesian and Timor-Leste agencies who facilitated this work, and to the ARC for funding it. Thank you.